Okay, so today's warm-up is going to be focusing on some midpoint stuff, a proof, some properties, things that we haven't seen in a while. So it's good review. These are actually the midpoint working backwards problems, guys. 2 of them. One with picture, one without, but it's the same problem. You definitely need to make sure you know how to do these. The EOC loves to use these when they do the EOC, the working backwards problems. It says, if the point at the top of the ramp of a coaster is 2, 8, so this is one of the endpoints, and the midpoint on the ramp is this, guys, this is the answer. This is the midpoint. What is the other endpoint? Well, the other endpoint is unknown, so it's going to be called XY, and it's going to be the other endpoint. Okay? When you do the midpoint formula, going backwards, you're going to have it set equal to something. So it's going to look like this. You're going to start with the x's. It's going to be x plus the other x is 2 divided by 2, and it's going to equal whatever the x is in the midpoint, which in this case is going to be 4. The other half of the set of ordered pairs is going to be the y, and then you're going to take and add it to the y that's in your other endpoint, so it's going to be y plus 8 divided by 2, and it's going to be equal to the y that is in your midpoint. The y that is in your midpoint is going to be the 5. You're going to multiply both sides by 2. Let me change colors just so you can see it really clearly. I like when y'all see it. So we are going to multiply by 2, multiply by 2, multiply by 2, multiply by 2. This 2 just cancels out the denominator, guys. There's no distributing it. There's not, no. This 2 cancels, and we just bring down x plus 2 equals 8. On the other side, the 2 cancels, and we bring down the y plus 8 equals 10. To solve each of them, we just have a one-step equation. We would minus 2, and x equals 6. Minus 8, and y equals 2. And you would have an ordered pair as your answer. Bless you. That ordered pair would have 6 for the x, bless you. And the y would be 2. 6 for the x, 2 for the y. Questions, concerns, anything about that? Anything you need to ask about?
Does it matter which x you use first?
Which, like if you did 2 plus x?
Yeah.
Not at all. Not at all. Now, this one, the one that is the midpoint, that's the only one that matters. That has to go after the equal sign. So the 4 and the 5 has to go at the end. And that's because it's the midpoint. This one, however, like between these two, you can write it as x plus 2 or 2 plus x. But again, the 4 and the 5 are the ones that have to stay over there by themselves. Okay? It's a very good question, yes?
Did you multiply it by 2, or why did you multiply by 2?
I had to get rid of the denominator.
Okay.
Yep. Anytime you have a denominator like that, in order to solve for the variable that's stuck on the top in the numerator, you got to multiply to get rid of it. Good. Okay, we're going to do the exact same problem again, but on number 12, it's the same thing. It just doesn't happen to have a picture, but it's still the same thing. We have a segment. It's AB. One of the endpoints is A. Here's the endpoint, negative 2, 3. This is the midpoint. Guys, if it's the midpoint, I like to make sure I box it in and write the M on there. That is the answer. That is the one that it's going to be equal to. And then they want us to find the other endpoint, which we're just going to call X and Y. So when I set up this parentheses, it's going to be, guys, X plus what?
-2.
Okay, so instead of writing plus negative 2, what's a better way to write that? Minus 2. All over 2 equals. And what is that one equal to?
4.
Perfect. You're seeing it now. Good. For the y's, it's going to be y what? Plus 3, all divided by 2. And it's going to be equal to what for the y? Negative 1. Awesome. Good. Made those. That's why I had 2 on this, because this is one of those things that kind of takes a second to absorb and remember. You're going to see this on the EOC, I guarantee you. Okay, to get rid of this, I'll switch colors again. To get rid of this, I'm going to multiply both sides by 2. I got to get rid of my denominator. That's how I get rid of my denominator, is multiply by 2. All it does is cancel it out. Nothing changes over here. It's just x minus 2 equals 8. Same thing on the other side, the 2 cancels out and nothing on the top changes, it's just y plus 3 equals negative 2. I'm going to solve each one of these by doing plus 2, x equals 10. Minus 3, y equals negative 5. Yes, should make sure my arithmetic's right. So my ordered pair would be 10, negative 5. What is that 10, negative 5? It's the other what? Endpoint. It's the other endpoint. Nice. Nicely done. Anybody have anything on either of the 2 problems at the top before we move on? I want to make sure everybody's got that down. Everybody's good on those. Anything about those 2 problems? Anybody still writing? Okay, here we go. The bottom ones, this is a proof. This is going to be proving triangles congruent. Guys, to prove triangles congruent, there are 5 ways to do it. I'm going to give you the first one. Side, side, side. Give me another one. Side, angle, side. What was it? Angle, side, angle. Can't curse. Can't curse forward or backwards. That's good. So AAS, there you go, AAS. And there's one other, but it's called different letters because it deals with right triangles only. Does anybody remember that one? HL, nicely done. HL, hypotenuse leg. If you have a right triangle, you can use that. That's the only time that works because it lets you curse without cursing. It's the only time ASS works is when you have HL and right triangles. Well, we can't call it that because you can't curse. So here we go, guys. First things first, number this. It'll make it easier when we go through and do the connections between them. Okay. So the first piece of information that's in there that's a statement, and we're only given the reasons, they give us the statements, is that CB, this line right here, is going to be parallel to GA, this line right here. To show parallel, you put those little triangles on there, top and bottom. Those lines are parallel. How do I know those lines are parallel? It's just given to us. It's in there. It's in the given information. It's right here. The second piece of information is that angle G is congruent to angle B. This is angle G right here. Mark it congruent to angle B. That's how you show congruency with those little congruency marks. Why do I know those angles are congruent to each other? Given. Okay. The next one says that AC is congruent to itself. Guys, what property tells me that something is congruent to itself? Nice. Reflexive property of congruence. Reflexive property of congruence. Okay. Now, the next one, you have to pay attention to the order the letters are given. Remember, the middle letter is the vertex. So I'm going to be marking angle BCA. BCA, that is this angle right here, is going to be congruent to angle GAC, GAC, which is this angle right here. Why are those 2 angles congruent? It's old stuff. Yeah, alternate interior angle theorem. There you go. Alternate interior angle theorem. You could say the actual theorem, which is that alternate interior angles on parallel lines are congruent, but that's a lot to say. Just say alternate interior angle theorem. It'll be easier. Okay, now look at the triangles. We have these things marked. I'll go over it in purple just to make sure. Oh, I'll do green. It's easier to cover up with. So I've got this, and this. What would that make that out of these 4? Which one of these reasons makes these triangles congruent? AAS. Angle, angle, then a side. An angle connected to a side. An angle, and then a side. Nice. Anybody have any questions on that one? Because the last one is properties. They're actually algebra-based properties to start off with, but they are used in geometry, like reflexive we just used. We just used that in our problem. So I'm going to go through and give you some examples. Just gonna go through these quick because they're pretty basic. Most people get them and see them, but they love to give properties on the EOC. Don't know why. Guys, if you start off with x equals x and you add the same thing to both sides, x plus 2 equals x plus 2, are they still equal? Yes or no? Yeah. That's all it's saying. That if you add the same thing to both sides, it's going to still say equal. Okay. Symmetric property of equality says that if I have x equals y, then that's the same thing as what? Y equals x. Perfect. Y equals x. Oh, you just told me reflexive, guys. Reflexive says that anything is congruent to itself. So if we just say x equals x, that's reflexive property. Anything is congruent to itself. And the last one, again, if we start with x equals x and we subtract the same thing from it, we'll just use the 2 because we used it in the first one. X minus 2 equals x minus 2. Will that make them remain equal? Will they still be equal if I subtract the same thing from both sides? Yes. That's why it's the subtraction property of equality. They will stay equal if you do that. Okay, guys, that's your warm-up. Please listen to me. Take out your folders. Turn to your warm-up page. If you have not written down the date for today's warm-up, please do